discussed molality, normality, then mole fractions, then percentage of solute. All those things we learned. The important one, the one more important one is about ppm. Have anyone heard about this ppm?
Network problem.
No. Okay. The full form of ppm is this come under in concentration of solution. Okay. You have one solute and you have one solution. So how much quantity of particular solvent, you can use this kind of formulas. So ppm is equal to, the full form of ppm is parts per million. Okay, this is a full form of ppm, parts per million. So formula is ppm is equal to, okay, number of parts of solute divided by total part, which means which is solution, okay, into 10 to the power of 6, into 10 to the power of 6. 10 to the power of 6 means what? What does mean by 10 to the power of 6? Mostly in the previous case we used only 100, right?
Because it's per million, ma'am.
Very good. It's per million. 10 to the power of 6 is for 1 million, right? So ppm is equal to number of parts of solute divided by total part, which is a solution, into 10 to the power of 6. So this is what. Again, how they'll give is 15 ppm. Let's take 15 ppm of salt in seawater. So what does it exactly mean is, you have a 15 gram of NaCl in 10 to the power of 16 gram of water. This is what very important. 15 gram of NaCl in 10 to the power of 6 gram of water. Are you people clear? Is there any doubt in the ppm?
No, ma'am.
Okay, fine. So this is also one of the concentration, to find the concentration of solute and then solvent. Okay. So now let's come to law of conservation of mass. Whether we discussed law of conservation of mass, constant proportion.
Yes, ma'am.
We did.
Okay.
Yes, now you people only have to say, are everyone clear in the concept? No doubt, small concept, limiting reagent, all those things, sir? I gave few problems in the last class, right? Based on limiting reagent, students? I gave few problems, I think 5 problems in the limiting reagent. How many of you did? Even if it is wrong, no issues, you can share in group, or else you can say me now, we will discuss the answer. Yes?
Sir.
No one did?
Good evening.
Yes, students, tell me.
நீங்க பாத்துட்டு வாங்க, நான் பேசிட்டு.
Okay, fine.
அவர் ஒரு 5 minutes ஆகுது, மைக் ப்ராப்ளமா இருக்கு. ஆக்ஸிஜன் உடைய
How
மூலக்கூறு
to
எடை என்ன?
calculate the
ஹைட்ரஜனோட
molecular mass by
மூலக்கூறு எடை?
using vapor density. Okay, so note down the formula. This is just a
மூலக்கூறு
formula,
நிறை,
no
எடை
need
இல்ல,
of
நிறை.
derivation. Okay, so formula is molecular mass is equal to,
அது ஆக்ஸிஜன்.
molecular mass is equal to 2 into
Hydrogen
vapor density. Okay, this is the formula. Vd in the sense vapor density. 2 into vapor density.
ஆக்ஸிஜன் மூலக்கூறு எத்தனை அணு இருக்கு?
Yes, students, am I audible to everyone?
Yes, ma'am.
Okay, whether we did empirical formula kind of sums, empirical formula and molecular formula sums.
I don't think
ஒரு மூலக்கூறுல எவ்வளவு ஆக்ஸிஜன்
we've done it in school, but yeah, I don't think so.
Yeah, yes.
ரெண்டு அணு இருக்கு. ஒரு ஆக்ஸிஜன் மூலக்கூறுல ரெண்டு
formula
அணு.
and then molecular formula into
அதே
this
மாதிரி
class.
hydrogen
Then I'll do some problems based on this. Most probably, I think I'll wind up to some basic concept of chemistry by today. If you have any doubts, you can post it in groups, or else you need of one more class also, you can let me know in the group. Okay. So write about the empirical formula and molecular formula.
எவ்வளவு கார்பன் அணு இருக்கும்?
Empirical formula. Okay. So yes, of course, I think everyone knows about empirical formula. It's a very basic topic. Tell me what's meant by empirical formula.
The simplest ratio of atoms to the molecule, ma'am.
Very good,
Ammonia.
super. It is a simplest ratio of molecular formula.
Okay, water
right?
symbol.
It is a simplest ratio of molecular formula. That is the
Water.
empirical formula. Very good. We'll go with one example. Let's take example is C2H4. This is my example. So what is the name of C2H4? Ethene. Okay. Yeah, very good. Perfect. It is an ethane. Now I can make this into a simpler way by dividing this by 2. Correct? Because 2 and 4 can be divided by a common number, which is 2. So that CH2 is my empirical formula. What is an empirical formula? This is the simplest ratio of molecular formula. After the CH4, the subscript of carbon and hydrogen, the 2 and 4 can be divided by common number. So here I am dividing by 2, so that it is CH2. CH2 is my empirical formula. Okay. Then tell me what is the relationship between the empirical formula and molecular formula? Empirical formula, you are clear, it is simply the simplest formula of molecular formula. Okay, let's take one more example. C6H12O6. So who is ready to say the empirical formula of this?
Ma'am, CH2O.
Very good, perfect. It is CH2O. So CH2O is my empirical formula. Okay. Then what is a molecular formula actually? What's the definition I can give? Similarly, like empirical formula definition, empirical is my simplest ratio of molecular formula. What is a molecular formula?
It's the actual number of atoms.
Very good, super. It is an actual atoms in the compound, right? It is an actual atoms present in the compound. Correct. It is an actual atom present in the compound. This is my molecular formula. Right. Very good. Super. Okay. How can I relate these two? How can we relate the both molecular formula and empirical formula?
Ma'am, molecular formula is empirical formula to end.
Very good. Super. Molecular formula is equal to empirical formula into n times. Okay, let's take the previous example. I have a molecular formula which is C2H4. Empirical formula is how much? CH2. So when the CH2 will become C2H4, then what should be the n value?
2, ma'am.
Very
N
good.
will be 2.
Yeah, n value will be 2. So like maybe as it is a very simple example, we can say it directly it is in 2. In case if it is complicated, you can do it like this. Molecular formula divided by empirical formula is your n value. Correct. This is your n value. I am just bringing the empirical formula into left hand side. Sorry, left hand side. So that n value is equal to molecular formula divided by empirical formula. Is there any other relations for this one? Is there any other relations?
இன்னொரு கரைப்பான் இருக்கு ரொம்ப கொஞ்சம் நீரை காட்டிலும் கொஞ்சம் ரொம்ப less popular.
Okay. The same thing we can relate in terms of mass also. Actually, molar mass or molecular mass, molar mass is equal to empirical mass into n time. Shall we relate like this?
Yes, ma'am.
Okay, into n. Why I am relating like this means very simple again. Okay, so you know the previous answer, the n value is 2. So let's take again C2H4. How to calculate the molar mass of C2H4?
Mass of carbon and mass of hydrogen. Carbon is 12 into 2 and hydrogen is 1 into 4, ma'am.
Super, very good. See, mostly the people, what the people are doing is, you are multiplying all the things. So 12 into 2 plus 12, not plus, 12 into 2 into 4 you are doing. Don't do that. Okay, the number of atoms multiplied by the atomic number, the same number of atoms, plus the other atoms you have to add it. Okay, the sum of the atomic masses. Okay, which is equal to empirical mass. I know the empirical formula. The empirical formula is my CH2. Let's take, I don't know the value of M. Okay, we don't know the value of M. Okay, then CH2 is how much? 12 plus 2 into 1. Correct?
Yes, ma'am.
Very good. So 12 plus 2 into 1. Then the next step is it should be a 16 and this to be 14. Am I correct?
saturated
Maybe.
solution
No,
தமிழ்ல
no.
என்ன
Yeah, yeah.
10, 14, ma'am.
மிகுதியான
Yes.
கெமிட்டியை கரைசலாம்
So 24 plus 4, this should be 28 and this to be 14 into N. Am I correct?
Yes,
Yes, ma'am.
Yes, I need to calculate the value of N. So N is equal to 28 divided by 14.
Which equals 2, ma'am.
Yeah, very good. So N value is equal to 2. So this is the way you can find the N value. Clear, everyone?
தமிழ்ல என்ன சொல்றாங்க உண்மை சொல்யூஷன்
Yes,
ma'am.
Okay. So far we didn't see this. Am I correct? Or
Yes.
else we have seen already this one.
சோ அது அந்த ட்ரூ சொல்யூஷன் என்ன
Okay.
தமிழ்ல
As I was taking with shuffling, it's a bit confusion. Maybe next time onwards we will go orderly so that I won't get
தெளிவான
confusion.
கரைசல்
Yes,
அதிகமிக்க
okay.
கரைசல் இன்னொரு ட்ரூ சொல்யூஷன்
Or everyone know that how to calculate the empirical formula from the percentage?
நாலுமே அது நீங்க என்னன்னு தெரிஞ்சுக்கணும்
Yes, ma'am.
Everyone knew how to calculate the empirical formula from the percentage?
கரைபோல் சொன்னா
Yes,
உப்போட
ma'am.
சிம்பல் என்ன
No. Okay. So we will do some simplest
NaCl.
example.
NaCl
Okay.
என்ன
For that,
apply?
I will take a basic one. Let's take for iron. Okay. You are giving only the percentage by mass.
நிறை என்ன
Okay. So question, iron percentage is given, which is 69.9 percentage, and then oxygen is given, which is 30.1 percentage. Are you clear? This is our question. 69.9 percentage and oxygen is 30.1 percentage. This is by mass. By mass means what, students?
சோடியத்தோட
What
நிறை
is the
23
mean by mass?
நைட்ரஜனோட நிறை என்ன
For 100 grams of it, there is 69.9
அதே மாதிரி
grams
chlorine?
of iron, ma'am. Like that.
Very good. Yeah, exactly right. Okay. So as it is a percentage, you can consider that it is an 100. Okay. So let's take 100 gram of the sample. So in the 100 gram of a sample, you know that there is an iron and oxygen. And iron percentage only given, which is 69.9 percentage. So for 100 gram,
தண்ணீரோட அடர்த்தி எவ்வளவு
69.9 percentage means you can say that this is 69.9 gram. Am I correct? See, for a 100 mark, you are getting 95. So what you will say in percentage? I am getting 95 percentage. Am I correct? It is a 95 percentage. Similarly, we are considering that the compound is for 100 gram. In the 100 gram, 69.9 is for iron means, the percentage means, I can take the same value in the gram. Similarly, the oxygen is 30.1 percentage means, which is 30.1 gram. See your students, is
தண்ணியோட
there
அடர்த்தி
any
ஒன்னு
doubts so
சொல்றோம்
far?
மண்ணெண்ணெயோட
No, ma'am.
அடர்த்தி
No, ma'am.
Okay,
ஆமா
fine,
0.8
super.
0.8
Next, what I need to do is, I have converted. I'll send you the document through WhatsApp. Okay, you don't need to
விளக்கெண்ணெயோட
copy
அடர்த்தி என்ன
anything. It's okay, I'll send the document in WhatsApp. So first you have to draw one tabular column
அது
so
வந்து
that it is very easy to calculate all
அது
those
தண்ணி விட
things.
கம்மி ஆனா
Okay.
மண்ணெண்ணெய் விட அதிகம் இப்போ மண்ணெண்ணெய் விளக்கெண்ணெய் சேர்த்தா எது மிதக்கும்
So here I'm going to mention what are the elements I'm going to use up here. The element involved is iron and then oxygen. Okay,
மண்ணெண்ணையும்
then
விளக்கெண்ணெய் சேர்த்து
let's write the
கலக்குறீங்கன்னா எது
percentage.
மிதக்கும்
The percentage of iron is 69.9 and then oxygen is 30.1. So the same thing I'm going to convert this into gram because we are considering that the compound in the 100 gram. So 69.9 can be written as like in the gram, it is 69.9 gram and here it is 30.1 gram. So next, who is coming? Number of moles. So what is the number of moles? What's the formula to find out number of moles?
Given mass by atomic.
by molar mass.
Very good. So it is my mass divided by either atomic mass or even I can say molar mass. There is no issues. Okay. So mass is actually 69.9 divided by 56. Okay. So what is 69.9 divided by
நகர்க்கும்
56?
பாதரசத்தை
I will do
நகர்க்கும்
it.
கோல்டு எவ்வளோ அடர்த்தி
Which is 1.24. So here I am getting 1.24. So next one, 30.1. Okay, 30.1 is for oxygen, the given mass. And what is an atomic mass of oxygen?
16.
You have to take only the atomic mass. Very good. You have to take only the atomic mass. Don't take the molar mass, students. Okay. You have to take only the atomic mass. So, so what is 30.1 divided by 16? Which is 1.88. Very good. 1.88. Then I need to find out simplest ratio. Okay. The next step is simplest ratio I need to calculate. Okay. How to calculate the simplest ratio? You have to select the least number from the number of moles. So 1.24 is my iron number of moles, and then 1.88 is the number of moles for oxygen. From this you have to take the least one. Which is the least one here?
Ma'am, 1.24.
So take the least one and divide it. You have to take the like for example iron means the iron number of moles is 1.24 and divide it by the least number. The least number, this is my least number of moles. Okay, least number of moles. So which is 1.24 divided by 1.24. How much 1.24 divided by 1.24? Yeah, it is 1. Yeah, 1. So next what I am doing, I am getting 1.88 number of moles for oxygen, but I have to divide it by the least number of moles, right? So what is my least number of moles here? 1.24. So 1.88 divided by 1.24 is 1.5. I am getting 1.5. Then only it is very important. See, listen carefully. If you are getting a whole number here, listen students, if you are getting a whole number here, then simply you can write Fe1 and then oxygen 1. Suppose this is also 1 and this is also 1. Then Fe1, oxygen 1. This we can write simply FeO. This is your empirical formula. Suppose oxygen is 2 means then FeO2 is your empirical formula. Okay, this is your empirical formula. Even in case the Fe is suppose 1.01, even 1.01 is also considered as single Fe and 2.02 is considered as 2 atom. But if it comes 5, 1.5, then what we need to do?
We'll have to multiply it by
Multiply it by 2.
Yeah, we have to multiply it by 2 so that we will get the whole number, right? So the next what I am doing? Simplest whole number. Okay, I am doing the simplest whole number. Okay, so simplest whole number is, as here I am multiplying by 2, this is multiplying by 2, the same thing here also you need to do. So this will be in 2 and this will be in 3. So what is the formula then?
Fe2.
Fe2O3.
Very good. So Fe2O3 is my empirical formula. Okay, this is not my molecular formula. So what you are doing in this table, you are calculating the empirical formula. Now, one more question is given here. The question is, one second.
Carry on.
Fe2O3 mass is given, which is 159. Okay, not Fe2O3, the molar mass is given. Okay, students, molar mass is given for this question. So what is the molar mass of the compound? Molar mass of the compound is given as, let's take 160, we will round off, 160 gram mole inverse is our molar mass. Okay, you found only the empirical formula mass, which is your Fe2O3. They are asking to calculate molecular formula. Then how you will calculate the molecular formula? Yes?
Ma'am, empirical formula
Empirical
into
formula into N.
Okay, see, molecular formula equal to empirical formula into N, but the molecular formula is actually you need to find out, correct? And even you don't know the value of N, correct? You don't know the value of n. You know only the empirical formula. So two things are unknown. Then how you will find a molecular formula? This is not possible. By using this formula is not possible. So we will change it as molar mass is equal to empirical mass into n. Okay. I know the empirical mass and molecular mass is also given in the question. Molecular mass is 160 gram mole inverse. And what is an empirical mass? I need to calculate. Fe2O3 is my empirical formula. So 2 into 56 plus 3 into 16. Am I correct? Right or wrong, students?
Yes, ma'am.
Okay, empirical mass in the sense simply the mass of the formula, right? So empirical formula from the table is Fe2O3. So 2 into F56 plus 3 into 16. So what it comes, what is 2 into 56 plus 3 into 16? Anyone did?
160.
Again it is coming 160. Okay. So now my empirical mass is also 160. So there is no doubt. What is an n value then?
It's 1.
It is 1. So 160 divided by 160, your n value is equal to 1. So if n is 1 means definitely the empirical formula is same as the molecular formula. Am I correct? Because n into empirical formula is your molecular formula. N value is 1 and empirical formula is Fe2O3. So just multiply this 1 into number of atoms of iron and number of atoms of oxygen. So again you will be getting the same answer. So this is Fe2O3. Clear, students? Is there any doubts?
No, ma'am.
Everyone are clear, right? Okay. So now, as you people are not asking the problems or any doubts, I am giving a problems. Okay? I'll give one problems. You try to think. I'll give you the steps how to calculate. You just do and tell me. It is very simple problems, but you have to think little bit.
Students, I think you have to ask questions. Otherwise, madam will give you problem. Better that we ask questions.
Yeah, yes, that's right, sir. See, if you have any doubts, please ask me, students. Okay, see, in the normality, we discussed about valency and all. Actually, there we used to say n factor. N factor is a perfect word, but in redox reaction, I'll teach you factor, how to calculate the n factor. That I'll teach you in detail. Okay, I'll teach you detail about the n factor there. Okay, so now I'll give you some problems based on limiting reagent, molarity, all those things. Okay, and even I will also do along with you people. Okay, so the question is very simple question. We will start from the previous years. These questions are actually from the previous year. Okay, very simple question. The number of atoms in 0.1 mole of triatomic gas. Okay, triatomic gas. This is a question. You have an options 1.8 into 10 to the power of 22, and then B is 6.02 into 10 to the power of 23, and C is 1.80 into 10 to the power of 23, and D is 3.6 into 10 to the power of 23. Triatomic gases, they are taking this relationship. I'll give you idea how to solve this problem. Okay, we know from the mole concept, 1 mole is equal to molar mass, and which is also equal to Avogadro number, and this is also equal to 22.4 liter. I know this very well. Here the relationship is about mole and then Avogadro number, because number of atoms, right? In the question it is number of atoms. So 1 mole and then Avogadro number. The relationship is about only the mole and then Avogadro number.
Ma'am, it's going to be Avogadro number divided by 0.1.
Avogadro number divided by 0.1. Perfect. Yeah, it's right. Avogadro number divided by 0.1. Yes, exactly right. Then what's the final answer? Yes, ma? What the final answer?
1.8, sorry.
Into 10 to the power 22, ma'am.
Very good, super. 1.8 into 10 to the power of
22.
22 or 23?
22, ma'am.
Is it 22? Actually, this is 23. Okay, we will solve, students. Very simple, actually. See, we know that 1 mole is equal to Avogadro number, right? 1 mole of any substances. Even if you have 1 mole of cash, this is hextrillion numbers, okay? Or if you have an hextrillion number, which is considered as a 1 mole. So 1 mole of any substance is equal to Avogadro number. So I can write 1 mole is equal to, what is an Avogadro number? 6.022 into 10 to the power of 23. Very good. This much. But my question is for 0.1 mole. Am I correct? Then 0.1 mole has how many number of atoms? Okay, how many number of atoms? Let's solve this question. So I need to find this x. Let's do crisscross. X into 1 and 0.1 into this one. So x is equal to 6.022 into 10 to the power of 23 into 0.1. Okay, 0.1 can be written as in some other way. Shall we write in some other way? 0.1. Yeah. How?
1 by 10, ma'am.
Very good. It is correct. 0.1 can be written as 1 by 10. Yeah, 1 by 10 is also written as 10 to the
To
power
the
of
power minus 1.
perfect. 10 to the power of minus 1. So this is because it is very easier to do like that. So 6.022 into 10 to the power of 23 into 10 to the power of minus 1. As my bases are similar, I can add or subtract the powers. Am I correct?
Yes, ma'am.
Okay. So 10 and here also 10. So 23 minus 1 I need to do because it is in subtraction minus 1. So my answer is 6.022 into 10 to the power of 22. That means for 0.1 mole I am getting this value. But why the answer is 1.8 into 10 to the power of 23 actually?
Because it's triatomic, ma'am.
Very good. Okay. Actually, let's take an O3 molecule. Okay. O3 molecule is my triatom. They are not asking number of molecule. I have told you this already. If it is a number of molecule, then this is your answer. 6.022 into 10 to the power of 23. But they are asking in number of atoms. So check how many atoms are present here. 3 atoms. They are given directly triatomic. Triatomic in the sense there are 3 atoms. So you have to multiply the final answer with 3. So this is 6.022 into 10 to the power of 22. 22 into 3 into number of atoms. Okay. This should be number of atoms. Clear everyone?
Yes, ma'am.
Yes, ma'am.
So if you multiply this, your answer will be actually 18.066 into 10 to the power of 22. Okay, this is your answer. If you multiply the 3 into 6.022 in 10 to the power of 22. See, actually 10 to the power of 22, you can keep it as it is. Just multiply 3 into 6.022. So that it is 18.066 into 10 to the power of 22 number of atoms. See the differences. Okay, here I am mentioning the molecules, but here I am mentioning the number of atoms. Why? Because this is for a triatom. They said for triatom. So multiplied by 3. Okay. Then what is 18.06 can be written as? This decimal is coming here. Okay, this is coming here. So that 1.8 into 10 to the power of 1. Okay, this will be your 1. If you move the decimal into the left hand side, it will be a 1, no, positive 1. And then into 10 to the power of 22. And if you add these two, 22 plus 1, again the base is same. And power you should add. So this is 1.8 into 10 to the power of 23. Clear everyone? So this is our final answer. Number of atoms. Are you clear? How many of you
ma'am.
have
Yes,
done?
ma'am.
Yes, clear, madam. Clear, clear.
Yes, sir. Okay. Yeah. Yes, let's move to the one more type of question. This is again very simple. Okay. Again, this is based on the mole concept. I'm expecting you people to say the answer. Okay. Very easy question. The question is the number of water molecule is maximum in. The number of water molecule is maximum in. I will give you one simple trick. Some values are given. Just convert all the values into number of moles. Okay, number of moles. A is equal to 1.8 gram of H2O and B is equal to 18 gram of H2O and then C is equal to 18 moles of H2O and then D is equal to 18 molecules of H2O. 18 molecules of H2O. Yes, students. See, I don't want you to do the correct answer. Okay, just tell me, convert the values into number of moles. That is enough for me. Just convert all the values into number of moles.
Madam, answer is C.
Answer is C. Okay, sir. Yes, students. Do it for A, do it for B, do it for C, and do it for D. Convert this into moles. I'm not asking you to solve the number of water molecules. Just convert this into number of moles.
Madam, can I give one more tip to the students?
Yeah, yes, sir.
Between
sure, sir.
A and B, B is bigger.
Yes, sir.
And between C and D, C is bigger. So now we have to find whether B and C, between B and C, which is bigger. I don't know whether I am right
Thank you,
or
sir.
not. Anyway,
Yeah, it's
that is the way I did.
right. Okay, sir. See, as sir said, if you compare the 1.8 gram and 18 gram, of course the 18 gram is a bigger value. Just eliminate this. You no need to even do for this case. If you compare between the B and C, B is given in the gram and C is given in the moles. So you convert this into moles, 18 gram of water. So what is the molar mass of water? 18. Am I correct? Then 18 gram is, it must be your 1 mole. Am I correct?
Yes, ma'am.
Yes, very
Yes,
good.
ma'am.
Yes, 18 gram is your 1 mole of water. Then 1.8 gram, it should be at 0.1 mole of water. Then 18 moles, this is already in the moles. We don't need to convert. Let it be as it is, 18 moles. This is an 18 moles. Then next one is 18 molecules of H2O. 18 molecules in the sense, it is not an Avogadro numbers. Okay, 18 molecules. We have only 18. Let's say 12 molecules of H2O. What does it mean by 12 molecule of H2O? I can say dozen of H2O. Am I right? You have only 12 numbers. Okay, you have only 12 numbers.
ma'am.
Yeah, so it is very, very lesser. This value is very lesser, even A. Okay, it is very lesser, even A. Okay, now 0.1 mole has 0.1 into Avogadro number of molecules. Then 1 mole has 1 into Avogadro number of molecules. And 18 moles has 18 into Avogadro number of molecules. Am I right?
Yes, ma'am.
Am I correct? Okay, then
Yes,
what is your
ma'am.
answer? Very simple, C is your answer. Because 18 into Avogadro number is your bigger value, so it must be your answer. Am I correct, students?
Yes, ma'am.
In this question, madam, if the question is like this, the number of water molecules minimum in, then what is the answer? Students, you tell me minimum. Which option?
Yes, sir.
D.
Ma'am, option D.
D is the
Exactly
answer.
right.
Correct.
Yes, D is your answer.
Option D.
Yeah, exactly right. Which is only an 18 molecules. 18 molecules is you can count in numbers, right? 18 molecular is your correct answer if it is a minimum. Okay. Shall we proceed to the next one?
Yes, ma'am.
Okay. So next question is about limiting reagent. Here I am solving a kind of basic and bit difficult question. But starting you can do very simple questions, and when you move to the next part, try to solve the somewhat difficult one. Okay? Yes. Very simple. The question is, when I'll write in a simpler way. No need to write the whole question. It will take time then. Okay. I have an H2 and then Cl2. Okay, H2 and then Cl2. So tell me, H2 and Cl2 it will form what? Hydrogen.
Ma'am,
Hydrogen chloride.
Very good. It will form hydrogen chloride. What is the question is, they are taking 22.4 liter of hydrogen and then 11.2 liter of chlorine. And they are asking to find out how much of HCl is formed. This is our question. Okay. And this they are giving in number of moles. So option A is 1 mole of HCl and B is 2 moles and C is 0.5 moles and D is 1.5 moles. What's your answer here?
1.5 moles, ma'am.
1.5 moles. May I know why it is in 1.5 moles?
Because H2, we've got 1 mole, 22.4 liters, and chlorine, we've got half a mole, 11.2 liters, so 1.5 moles, ma'am.
Okay. Is there any other different answer, students? Is any other different answer? Okay. So the answer is not 1.5 mole. This is
Ma'am, 0.5, ma'am.
0.5. Why it isn't 0.5? Yeah, yes. Why it isn't 0.5? Actually, I
Ma'am,
think...
there is only 11.2 liter of chlorine.
Okay.
So we can't be the excess of hydrogen.
Oh, exactly right. Perfectly right. But one thing you have missed. You didn't balance the equation. Limiting reagent means we have to balance the equation, right? What you did is exactly right. Perfect. But you have to multiply into 2 so that the correct answer is 1 mole. Okay? Because H2 plus Cl2 will give you 2 HCl. Am I correct, students? Right?
yes, ma'am.
Okay. So 22.4 liter, which means this is my 1 mole. All the 22.4 liter is my 1 mole. Am I correct? Then what is 11.2 liter, which is 0.5 mole? 22.4 liter is my 1 mole, means 11.2 liter is my 0.5 mole, because we know that all 1 mole of gas at STP is 22.4 liter. This is 1 mole of hydrogen, 1 mole of a chlorine, and this is 2 moles of HCl. So what is my limiting reagent? No doubt, chlorine is my limiting reagent.
Chlorine is limiting reagent.
Exactly right. This is in 1 mole, means chlorine should also be in 1 mole, but this is 0.5. Then 0.5 is my limiting reagent, chlorine is my limiting reagent. But so limiting, what is the role of limiting reagent? The product will be formed based on the limiting reagent, right? So this is 2 into 0.5, because 2 is a stoichiometric coefficient for HCl. You have to multiply 2 into 0.5, because 0.5 is my limiting reagent mole. So 2 into 0.5 will be your 1. So 1 mole is 1 mole of HCl is your correct answer. Clear, students? Do you have any doubts?
Yes, ma'am. Ma'am, how to find the limiting reagent?
Okay. See, I have explained in detail already. Anyway, I'll say the question is H2 plus Cl2 will give you 2 HCl. First, you have to balance the equation. The equation is balanced now. I did already. So the standard equation, write a standard from that. You are taking 1 mole of hydrogen, because the stoichiometric coefficient here is 1. And 1 mole of a chlorine will give you 2 moles of HCl. This is a standard one. Okay. From the balanced equation, I am writing. Okay. Then what is given in the question? They are giving a volume The volume for H2 is 22.4 liter and for a chlorine is 11.2 liter. This is given in the question, right? Okay, then I know that 1 mole of any gas is equal to 22.4 liter. Okay, then if this is a 22.4 liter, definitely this is an 1 mole. Now I am writing here in terms of mole. So 22.4 liter is for 1 mole. Then what is 11.2 liter? So 11.2 liter means it is an exactly half of this. 22.4 is exactly half of 11.2. That means this should be my 0.5 moles. Am I correct? So
Yes,
from
ma'am.
here- okay, yes. So this is a 0.5 mole. So just compare this value with the standard one. Okay, 1 mole of hydrogen need of 1 mole of chlorine. So 1 mole of a hydrogen need of 1 mole of a chlorine, but you have only half a mole. That means you have lesser value, right? Am I correct?
Yes, ma'am.
So this is your limiting reagent. Okay, now this is your limiting reagent. Okay, LR. This is your limiting reagent. Now they are asking to find out the HCl. So HCl means how you have to calculate. So the limiting reagent, see check, 1 mole of a chlorine. From the standard I am comparing. 1 mole of a chlorine is giving 2 moles of HCl. I will write chlorine here and then HCl here. 1 mole of a chlorine is giving 2 moles of HCl means then 0.5 mole of a chlorine definitely will give you 1 mole. This is the twice. And what is the twice of 0.5? 1. Am I correct?
Yes, ma'am.
Yes, ma'am.
Even if you take x also, you can do the crisscross and you will find the answer. Hope it's clear, students. Is there any doubts?
No, ma'am. It's clear.
Okay, fine. Okay, now let's come to the molarity type of questions. Okay, even if you haven't any doubts, you can ask me, students. Okay, let's move to the next one. They are asking to find out the molarity actually. Molarity. Molarity you need to calculate. Okay, this is for Na plus ions in Na2CO3. Find the molarity of Na plus ion in Na2CO3 and mass of the Na2CO3 is given. Mass of Na2CO3 is 25.3 gram and volume of the solution is 250 ml. Okay, so I'll give you 2 minutes time. Just go through what's the formula for molarity. Tell me the formula and how I have to approach here. The important one is you people have to think a lot. That is very important when it comes to any competitive exam. Don't just mug up or memorize and give your answer. Just think. Of course, it is easy. You will get the answer, no doubt. Okay, what is the formula for molarity?
Number of moles of solute by volume of solution in liter.
Okay, very good. Number of moles of solute divided by volume of solution in liter. We have put the number of moles as actually weight divided by molar mass, and then volume of solution is changes into 1000 divided by volume of solution in ml. We did this formula in the last class, right? Right? I am just substituting it. Okay. Yes. Okay. So now what I have to do is the weight is given. Weight, mass, everything is same. So the weight is actually 25.3 divided by molar mass of Na2CO3 I need to calculate. So how we will calculate the Na2CO3 molar mass? 2 sodium, so 2 into 23 plus 1 carbon, so 12 plus 3 into 16. So what is the answer? 2 into 23, 46. 46 plus 12. So what is 16 into 3? 32 and then 48, no? 48. 48. So what is 46? Let's do this. 48 plus 12 is how much, students? I mean, yes?
60.
What is the
60,
answer?
ma'am. 60.
Okay, 60 plus 46 is?
106.
Okay, so molar mass of Na2CO3 is 106. So weight divided by the molar mass of Na2CO3, which is 106, into 1000. What is the volume of solution in liter? What is the volume of solution in ml? Sorry. What is the volume of solution in ml, students? How much is given in the question?
250 milliliter. 250
Yeah.
milliliter.
It is 250 ml. Okay. I will solve the question. We will directly move to the answer, which is 25.3 into 1000. 25.3 into 1000, which is 25,300. 25,300 divided by 106 into 250, which is 26,500. Am I right? Okay. So then we have to divide it. 25,300 divided by 26,500. Your answer is 0.95 molar. Am I correct? 0.95 molar. Is it right or wrong? Is it right or wrong? Molarity is molar. Even you can use the word mole liter inverse. But there is one more step which is very important. They are not asking to calculate the molarity of Na2CO3. They are asking for Na plus ions. So tell me how many Na plus ion in Na2CO3? How many Na plus ions? Na2CO3. How many sodium atoms are in Na2CO3?
2 atoms.
2 atoms. So you have to multiply this answer into 2. So that 0.95 into 2. So which is 1.91 molarity. This is your answer. This is the concentration of Na plus ions. Clear now everyone? Students, are you clear? Okay, see, even in case if you have any doubts, see this video once again. Definitely it will be very clear. Okay, all the points here I have noted down stepwise only. As they are asking for Na plus, we are multiplying this by 2. Okay, it is very simple cases. We are just directly substituting in the formula. Okay, let's do one more question. See, H2 plus O2 will give you H2O. So the question is, they are taking 5 moles of hydrogen. Tell me how much moles of water is formed. This is a question. 5 moles of hydrogen reacts with how many moles of water? How many moles of water is formed if you took 5 moles of H2? Yeah, tell me students. Is it a difficult problem? Why people are not answering?
Ma'am, do you please repeat the question again?
Okay, the question is 5 moles of hydrogen will give you how much moles of water? 5 moles of hydrogen will give you how much moles of water?
Now 5 more, ma'am.
5 moles. We will solve. Before going to do that, you have to balance the reaction. So on balancing, 2H2 plus O2 will give you 2H2O. So from the standard, it is very direct. 2 moles of hydrogen will give you 2 moles of water. Then, of course, if you take 5 moles of hydrogen, it will give 5 moles of water. So 5 moles of water is a correct answer. But you have to balance this, then only you have to give the answer. If two reactant mole is given or gram is given means then you have to find the limiting reagent. But here in the question, they are comparing with the one reactant and they are asking how much moles is formed. Then we can just directly take the ratios and we will find the answer. Just do crisscross, you will get the answer. Are you people clear?
Yes, ma'am.
Okay, yes. So next I'll move with a mole fraction kind of question. Try to understand this one. The question is they are asking to find out mole fraction. Okay, mole fraction of solute we have to calculate. This is a question. For 1 molar solution, the given is 1 molar. Okay, 1 molar is given. What is mean by molar in the sense? I have explained in detail what is mean by molar. What is mean by molar?
Moles per kilogram.
Very good. Moles per kilogram. Exactly right. Which means 1 mole in per kg. Right. 1 mole in per kg of solvent. This is the thing. And this is an aqueous. Okay. Aqueous means then what is the solvent used? Aqueous means what is the solvent?
Water.
Exactly right. This is an water. So we know that we don't know what solute it is. Simply they are asking the mole fraction of solute. First I will write the mole fraction of a solute formula and we will do it one by one. So mole fraction of a solute. What is the mole fraction of a solute formula? Tell me the mole fraction formula. Number of moles of
Number
solute.
of moles of solute by mass of solvent in kilogram.
No, solute. It is a mole fraction. Number of moles of a solute divided by number of moles of a solute plus number of moles of solvent. See, we did actually XA is equal to Na divided by Na plus Nb. We did know. Na plus Nb. The same thing. XA is equal to Na divided by Na plus Nb. The same thing here we are doing. So N solute divided by N solute plus N solvent. I know the value of N solute. 1 mole is my number of moles. This is my N value, 1 mole. Okay, now number of solute is known and number of solute is known. I need to calculate the number of moles of solvent. That is also very easy. So what is a solvent here? Solvent is your H2O, correct. So how to calculate the number of moles of H2O? Given mass divided by the molar mass. So what is a given mass? Per kg, correct. 1 kg. So 1 kg. How you will convert 1 kg into gram? Because molar mass you will be taking in gram. H2O molar mass is 18 gram. But mass, the solvent is given in per kg, right? So it is on 1 kg. So how you will convert this into kilograms?
1 kg into 1000.
Very
1
good.
kg equal to 1000 grams.
Yeah, 1 kg into 1000. So it is 1000 divided by 18. Then you got the number of moles of H2O also. So 1000 divided by 18 will be 55.5. 55.5. So number of moles of H2O is equal to 55.5. Listen student, very important thing is 1 molar. 1 molar in the sense which is 1 moles. Okay, 1 moles of solute in 1 kg of solvent. So my number of moles of solute is also 1 mole. Then number of moles of H2O is also 1 mole. Then how we will calculate the mole fraction of solute? Mole fraction of solute is equal to N solute divided by N solute plus N solvent. So I know the N solute value which is 1 divided by N solute is again 1 and N solvent is 55.5. Am I right? So 1 divided by 56.5 is your mole fraction. So what is 1 divided by 56.5? Which is 0.017. So the mole fraction of a solute is 0.017. Are everyone clear now?
Yes, ma'am. It's clear.
Yeah?
Yes, ma'am.
Yeah, okay. Yes, fine. So I think we'll wind up till this for today's class. Just go through, be interactive in the class, okay? Mostly everyone are not answering. Why? What's the reason?
They are all hungry, madam.
Hungry, that's the reason. Okay, yes.
Yeah.
I don't want to, that's the reason I'm just
Yeah,
stopping
actually the
now.
students, when you come to the class, நீங்கள் அப்பமே சாப்பிட்டுட்டு வந்துடணும். ஒரு half the வயிறாவது சாப்பிட்டுட்டு வந்துட்டீங்கன்னா தான் only when you have food in your stomach, your brain will work. So, கொஞ்சமாவது, I mean, not full stomach, half stomach நீங்கள் சாப்பிட்டு வந்துடணும். But unfortunately, madam, the students வந்து, I'm sorry to say this, எல்லா ஸ்டூடெண்ட்ஸுமே they are weak-ஆக தான் இருக்காங்க.
Okay.
I mean, that's my general comment, பொதுவா. Not that they don't take the food, the right kind of food எடுக்கிறதில்ல, because எல்லாமே மருந்தடிச்ச காய்கறி எல்லாம் வருது, and they don't take in the right time also. So that is my observation. Anyway, thank you, madam. I think it was quite interesting. I listened about half an hour பார்த்தேன். It's quite interesting.
sir.
Of course, it is quite absorbing, rather, I would put it that way. It's quite absorbing. But then I had some other work. Another class is going on,
Okay,
Tamil
sir.
class. So a little bit here and there I was wondering. Thank you so much.
Okay, sir.